Linear approximation. In mathematics, a linear approximation is an approximation of a general function using a linear function more precisely, an affine function. They are widely used in the method of finite differences to produce first-order methods for solving or approximating solutions to equations. Definition and definition. Applications: optics, 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 ticks, optics, 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 optics. Gaussian optics is a technique in geometrical optics that describes the behavior of light rays in optical systems by using the paraxial approximation, in which only rays which make small angles with the optical axis of the system are considered. In this approximation, trigonometric functions can be expressed as linear functions of the angles. Gaussian optics applies to systems in which all the optical surfaces are either flat or portions of a sphere. In this case, simple explicit formulae can be given for parameters of an imaging system such as focal distance, magnification, and brightness in terms of the geometrical shapes and material properties of the constituent elements. Period of oscillation. The period of swing of a simple gravity pendulum depends on its length, the local strength of gravity, and to a small extent on the maximum angle that the pendulum swings away from vertical th0, called the amplitude. It is independent of the mass of the bob. The true period t of a simple pendulum, the time taken for a complete cycle of an ideal simple gravity pendulum, can be written in several different forms. See pendulum, one example being the infinite series, where L is the length of the pendulum and g is the local acceleration of gravity. However, if one takes the linear approximation, i.e., if the amplitude is limited to small swings, the period is. In the linear approximation, the period of swing is approximately the same for different size swings, that is, the period is independent of amplitude. This property, called isochronism, is the reason pendulums are so useful for timekeeping. Successive swings of the pendulum, even if changing in amplitude, take the same amount of time. Electrical resistivity.